Hello and welcome everyone to Intel on AI. I am really excited about today's show. But first off, I want to say hello to my fellow co-host, Tony. How's it going?
It's going pretty well.
Good to have you here. So we've got a wonderful guest today, Vasudev Lal from the Intel team. How's it going today? Have you already coded today? What's happening?
Yeah, I'm very excited to be here. So thank you, Ryan. And yes, I did train a foundational model for breakfast today. No, I'm just kidding.
That's what I like to hear. Love it. So Vasudev leads the cognitive AI team at Intel Labs, where his team is extremely interested in pushing the state of the art in AI using Gaudi-based AI clusters in the Intel Tiber Developer Cloud. It is really good to have you on the show today, and you have deep knowledge that I'm excited about sharing with our listeners. So I want to kick it off with question number one, which is, how do you envision multimodal AI systems being applied in real world business scenarios? We're looking to improve decision-making, customer experiences, operational efficiency, or something else.
Yeah, that's a great question. So, a lot of my team's work has been around multimodal AI over the last 3 years. And one of the primary motivator for that was that a lot of the world's data is multimodal. It is a mixture of text mixed in with images and video and audio. So for example, if you consider business documents, like PowerPoint slides or, other kinds of business documents, they tend to contain, a lot of figures, graphs, tables, pie charts, diagrams. And if you truly have multimodal models, then your solution, your AI solution, can encompass all the knowledge and information which is present in all of these modalities. So, if you want to create a search system or a chat bot that is aware of your business documents, then you want it to be able to understand all these images and graphs in your business documents, and you will need the multimodal AI. So that was one of the practical applications that drove our interest in multimodal AI. There are some other interesting things about multimodal systems from a conceptual point of view. If you're interested, I can get into that as well.
Well, I think because of the audience that we're really talking to, I think it's looking more at like the business perspective. From that perspective, you've mentioned you've got different documents and things like that. What are the limitations that we have right now to take advantage of this multimodal AI for like a business use case?
Yeah, so I would say that, some of the limitations are that fundamentally, the way images and figures are going to be processed by AI models are that, they're going to be split up into small pieces. And those small pieces are going to act very similar to how words act in language models. But because of that, you can imagine that, if you have a lot of business documents with a lot of these figures, you're going to get a very long stream of, what are called these image tokens that feed into these large models. And that becomes a limitation when you go to multimodal systems right now. So that is also something that our team is very actively working on, that, how does the compute scale as you go from language, which is a very discrete modality with, very concise vocabulary, to something that is going to be a combination of language and images or language and video, where images and videos are continuous modalities. So I think that is the biggest limitation right now, that, how do we devise architectures that can efficiently, in a computational sense, process high dimensional modalities like images and video.
So I have a question about that. So if someone is thinking about training a model or fine-tuning a model for their enterprise so they can start to extract some of the value from all the data they have, and they have multimodal data, how they need to think about labeling the data and then training on that data? Are they going to have to hire a team of ML engineers or a large team of staff to label the data? Like, how does this actually work in reality?
Yeah. So that is an excellent question. So I think a lot of the paradigms of self-supervised training that has been applied for training models on internet scale data also apply here. So for example, If you have multimodal data, you can always extract pairs of, like, let's say a figure and its description because they appear on the same slide. And that creates this weak correlation, right? That a figure goes with a certain, either conclusion or a description. And because of this, probably in this first step, you don't require intensive human annotation. You can just simply mine the data to find proximate image text pairs that you can use for training these models initially.
So for instance, if you had a PowerPoint and there was text in that slide that talked about some of the imagery, then you have light correlation and you start
exactly. Yeah. So then you can train a model to try to understand that, this is what, the conclusion or the summary was, and that, the model gets to associate that figure or diagram with that text on that slide. And if you do this at scale, let's say if you are able to do this at scale on, business documents that, a large organization uses, then that model will really get accustomed to seeing and understanding that kind of multimodal data without, a lot of human annotation of that data.
Okay. And so if we step back a little bit, we've had some people on already to talk about the differences in terms of like what you need in terms of software, in terms of hardware and the possibilities of AI. But since you're a very technical person, can you up-level it for us? And for those who don't truly understand the math behind AI model training and inference, can you give us like a 30,000 foot view of why we end up needing more and more compute to do this?
Yeah, that is an excellent question. So I think, about 15 years ago, people realized that instead of writing complex computer programs, if you annotate some data and train neural networks, the neural network actually does much better. And, these were tasks like, trying to detect a cat in an image or a dog in an image, where just annotating a little bit of data and training neural networks on it ended up being more effective than writing complex, computer vision algorithms around it. Now, from that initial breakthrough 15 years ago, people then figured out that as you increase the data that you train these neural networks on, and as you increase the size of these neural networks, the performance of these models keep getting better and better. So, there was the signal that, we need more and more compute for these models. And then something really interesting happened about 7 to 8 years ago, where people figured out that you don't need human annotation to train these models. So that is now what is called self-supervised learning. That you can take all the internet scale language data, for example, and you can make some tasks that can be used for training models with no data that a human needs to annotate. And what that opened up was this massive data pile where you can train models, and to really absorb the knowledge from this massive data pile, you have to scale up model sizes. And that leads us to the situation today where there are huge data sets and huge neural networks that get trained on that data. And consequently, we have a world in which, we need massive amounts of compute for training these models and then for deploying these models in production.
Wow. So I know that one of your research interests is incorporating counterfactual reasoning and principles from causality into AI systems. Could you give us a quick definition of what that means in a kind of normal speak for both me and maybe some of our listeners? It sounds fascinating. I'd love to learn more.
Yeah. So our team takes a lot of inspiration from psychology and even neuroscience as we study artificial intelligence. So counterfactual reasoning is a concept that actually comes from human psychology and behavioral studies. And in simple terms, what it means is imagining what might happen differently in a situation. So that is what counterfactual reasoning means. And it is thought that, when kids are growing up and learning, they learn a lot about the world by posing these counterfactual questions.
What would be what's like a real world example of that?
Yeah. So for example, a kid might ask, a question of himself or herself that, what might happen, if they were to go push a bowl off the table, right? And sometimes they might actually do it, unfortunately for the parents. But that's how kids learn about the world. They ask counterfactual questions. They are trying to figure out what might happen if something changes and so on. So our goal has been to apply a similar technique for AI systems, to probe and teach an AI model what might happen differently. So for example, if there is an image and that image has a kitten in it, if you replace that kitten with an image of a lion, how does the meaning of that image change, right? And the same thing applies to, sentences and language input. And what we've actually shown in some of our recent projects from our team is that if we create these counterfactual examples and we train models on these, we can significantly improve the performance of our models. We've also created such counterfactual examples to show how we can probe biases in models and we can mitigate biases also. So I hope that explains what we mean by counterfactual reasoning in our model.
Thank you.
Yeah, that's very interesting. And the other thing that I think that people would really be interested in, I know your team has done a lot of work in this area, is around explainable AI. And I think that there's a lot of questions people have. You talked about the large data sets that are required, et cetera.
Yeah,
but can you explain, why do we care about explainable AI, and how are we trying to make sure that we have explainable AI from Intel?
Right. Yeah. So, a lot of our focus has been on trying to understand how these deep learning systems work, right? And as researchers, we want to develop tools that help us understand the inner workings of large language models, transformers, and so on. And what this helps us do is it helps us, root cause why these models fail in certain situations. We can inspect the internals of the model and understand, when are these models accurate? When are these models not accurate? When do they hallucinate? Versus, when are they actually being able to tell something factually? So we often have this philosophy that we want to build these interpretability tools, these explainability tools, to help understand the inner workings of these models. And then we use it in a feedback mechanism that, once we then understand, how do these models actually work in a more, from a more fundamental perspective, it can often give us insights as to how we should improve these models. Like, what should we change in the architecture? What should we change in the data strategy that we have for training these models? So we really use interpretability and explainability as a tool to understand how we can improve these models as well. And, I really believe that, ultimately people have to trust these models. So, nobody likes trusting, a black box, right? Everybody would rather trust some system that, they have some understanding of its, of its basic functionality. And so we are really interested in ensuring that we can create this kind of trust in AI systems by showing that, they are explainable, interpretable, and building more AI models that are more interpretable and explainable.
Got it. What are some recent trends that your team is really excited about or interested in? What gets you really fired up right now?
Yeah. So we are really excited about this concept of AI agents. And people also refer to these as agentic AI workflows. And it's about, not having just one model take the input once and giving you an output, which is, the predominant paradigm of today. But if you have a complex task, how do you get an AI agent to first do some planning? That, this complex task needs to be broken down into these, 4 or 5 steps. And then in some of those steps, you might need to call very specific tools. Like maybe you want to call a tool that helps, find a bounding box on an image. Maybe you want to then in the next step, call a tool that does some sentiment analysis and so on. And then, you chain up all of these tools and then execute on the plan and solve the task. So this is something that we are very interested in, because I think it's kind of similar to how humans solve a task, right? That we break down a complex system into simpler steps, we iterate over it and so on. So this is one kind of workflow that we are really excited about.
Do you think though agentic behavior is just going to be built kind of out of the box so that a lot of folks that are, leading companies are going to expect these things to work, or is there going to be a lot of development and engineering and hand cranking that has to happen?
Yeah. So I think they probably are going to go hand in hand where, given the current generation of AI models, then you would be able to use them in agentic AI workflows to do something that, they cannot do standalone as an AI model. But then once you have that AI agentic workflow, you could maybe create some data from that workflow that you try to train your next generation of foundational models for which you might not need that complex flow. So I think it's probably going to go hand in hand. But this is, again, I think it's trying to peer into the future of how this is going to develop.
So I want to take advantage of having you here. Obviously, having worked at Habana, Gaudi has a really big place in my heart. And I was curious, you work with Gaudi 2 a lot for the models that you're building and you're working on and the work that you do. Can you tell me what you find really great about working with Gaudi, and potentially what are you looking forward to when it comes to Gaudi 3?
Yeah. So, our team has been working with Gaudi-based clusters for a few years now. One thing that we exploit a lot about Gaudi 2 is that Gaudi 2 has quite a lot of HPM, 96 GB HPM. And what that really helps us do is squeeze really large models that we can use on Gaudi 2. When we are training our models, we are able to squeeze large batch sizes, and that increases our overall throughput of training. So that's something that we exploit all the time. Another thing that we really make use of is, Gaudi supports really fast intercommunication between different Gaudi accelerator cards. And, when we are typically training new models, we need to train across a cluster of Gaudi 2 cards. And in this regime, typically, the intercommunication speed between the AI accelerator is what really limits the total training throughput, not, the performance of one individual card. And, there we've seen very good scale out capability. As we scale out from 2 or 4 Gaudis to, hundreds of Gaudi 2s, we get a very good scaling factor, and, we exploit that a lot in our research.
Awesome. Thank you. So I know that your team releases a lot of models and data sets on Hugging Face, and it's becoming this new treasure trove of value and interest for companies around the world. But if a company is thinking about actually leveraging a data set or a model from Hugging Face, what are some things that they need to think about in order to protect themselves or take advantage of things that they're not?
Right. So I think, probably the first thing is to, pay really close attention to the license of the data set or the model, right? Especially if you're thinking of commercial deployment. You really want to make sure that if you're picking up an open source model, its licensing is consistent with, how you're going to be deploying it for commercial use. So I would say that's probably, the most important consideration. And then other considerations would be that, if you're going to pick up a model, what is your target compute, right? Like, are you targeting something that's going to run on data center, Gaudi cards or Xeon, or, is it an application you're trying to develop that's going to target a client device, right? So that's going to determine, what model sizes you want to sample. So I think those are the two that immediately come to my mind.
So with all the technology that we have, there's a lot of interest in how do I integrate this into my business? And a lot of people are concerned about kind of the bridging the technical and the ethical implications of using AI in regular everyday jobs. So how do businesses think about this technology? How do they strike a balance between leveraging the power of AI because they have to remain competitive with other people who are using it, and ensuring that the technology is used in a responsible way that benefits everybody?
Yeah, I think that's an excellent question, because I think with all previous technological innovations and revolutions, there has been a net creation of jobs. With AI, there is this perception that with AI, this could be different. The current state of AI, does threaten a lot of traditional job roles. So I think for a large part, this perception of fear is, well founded. That, and I think as technologists, we have a responsibility that, we develop AI in such a way that it complements human capabilities. It's not meant as a replacement for, things that humans do, and especially things that humans enjoy doing. But it serves to, make better human AI collaboration possible. It augments human creativity. Maybe it helps more with tasks which humans don't like to do, or are dangerous, or are just tedious and repetitive, right? So maybe those are more of the applications. So I think the right incentives need to be there, that are placed by policymakers. But as technologists, we should also be aware of it, that we play a very big role in guiding how AI shapes up. And a lot of effort should be on that. This should be technology that augments human capabilities and not replaces it. Yeah.
Awesome. Thank you. So we're going to close out the show with you giving some advice or some homework to our listeners. So if you want folks to go out and massively improve the way they're using AI, or thinking about AI, or learning something about AI, what kind of homework do you want to give our listeners?
Yeah. So I think, for someone who wants to, do something hands-on with AI, I think nothing is better than picking up a problem statement that you might be really interested in, and then, using AI to solve it. And, it could be something as trivial as this, that, let's make an object detector for your pet, or let's make an object detector for your family members. But choosing a project that, is going to keep you engaged and, it'll excite you, and then figuring out tools that you can use to make that AI solution, I think is just the best possible way to get a hands-on experience. Yeah. And, for someone that's not interested in more hands-on work, but, more on the business side, I would say that probably the most important thing would be an exercise in which is the problem statement that you want to apply AI for. Like, which problem statement can the right data set be curated? Can the right problem statement be made for which you can deploy AI for solving that problem?
Fabulous. Well, Vasudev, thanks for your time. You are a very busy person, and we appreciate you dedicating some time to us and our listeners. Tony, thank you as always for being an amazing co-host. And everybody listening, appreciate your time. Please keep in touch and follow us on X and on LinkedIn. We'd love to chat with you all some more. Vasudev, where can folks find you online if they want to learn more?
Yeah, I'm quite active on LinkedIn. That would be the best place to find me.
Love it. All right. Thanks, everybody. And we'll see you next time.
Thank you, Ryan. Thank you, Tony.